So, hi guys, my name is Jacek, and as a member of the Meet and Code team, I'd just like to briefly introduce you to the initiative and just say a few quick words about the project. But first, a very warm welcome from our partners, Hasso TechSoup Europe, SAP, and German Federal Ministry of the Interior. I think we can begin. Welcome to our another Purpose Talk session. And if you're new, just let me tell you a bit about Meet and Code. Because Meet and Code was launched in 2017 to simply assist nonprofit organizations in providing digital skills education to young people aged from 8 to 24 years old across Europe. And now, 5 years on, Meet and Code has reached more than 175 young people across 35 European countries. So that's a lot, and I'm super proud of that. And giving them the digital literacy and coding skills to, let's say, thrive in tomorrow's competitive digital economy. And Meet and Code basically awards micro grants of as much as 500 euros to local nonprofits to facilitate the workshops and classes they deliver. And many in our audience today, I think, may be recipients of those grants. And why have we launched the Purpose Talks? Because that's also important. The Purpose Talks series is just an extension of the Meet and Code commitment to help nonprofits become more innovative and creative in the work they do. They are basically designed to inspire all of you guys, our Meet and Code community, with different learnings and insights from our leaders in the exciting world of IT and coding, let's say. But I think it's the highest time to introduce our dynamic and amazing speaker of the day. And as I said, we are delighted to have no other than Jens Mönich with us today. And Jens is a researcher at SAP. He's also the architect and lead programmer of UC Berkeley's Snap programming language, for which he has been awarded the US National Technology Leadership Symposium Educational Leadership Award of 2020, together with Brian Harvey. And for those of you who are not fully aware, Snap is a well-known block-based programming language that allows you to build your own blocks. And simply by stacking together graphical blocks rather than just typing words, your program is always alive, ready to be tried, tested, and changed as your ideas evolve. So, but I don't want to give too much away. So coming back to Jens, he also has conducted research under Alan Kay, helped develop Scratch for the MIT Media Lab, and written enterprise software. He's a fully qualified lawyer in Germany, and he has been an attorney, corporate counsel, and lecturer for many years before rediscovering his love for programming, let's say. We are honored, super grateful, and hugely amazed that despite all your commitment, Jens, you found the time to be with us today. As I said, I'm super excited, and I think it's highest time to start the session. So Jens, over to you.
Thank you, Jacek, and hi, everybody. Thank you very much for the invitation. I have to say, always when I'm kind of giving a talk, I'm really, really anxious. And just as we were talking before, one of the problems is that these talks are recorded, so I can't give the same talk twice, really, especially since I know some of you who've joined this talk. Please bear with me. I'm going to share my screen in a minute, and I'm going to start with something that many of you might have seen me show before, but that's only the beginning. I'm actually going to try to show something completely different and new today, and it might not even work. So if it doesn't work, I'm going to ask you to help me debug what I'm going to code. So I'm going to share my screen and start with an overview. And this is the part that you might have seen before. So bear with me. This is a little background on Snap. This is how I usually introduce myself, that I'm Jens Mönich, that I research into interactive visual programming, which is the kind of programming that does not look like what you see on the screen right now, but it's actually something where we spatially arrange things to give them a meaning, where there is a graphical quality to what we do. And so for the past really dozen years, I've been asking myself the question, like, how do you write software for kids? How do you make a programming language for kids? And basically, much of my work has gone into this programming language, Snap, build your own blocks, that I'm going to show you today. So when they once asked Russian playwright Maxim Gorky, who wrote children's books, like, how do you write books for children? This is what he answered. He said, the same as for adults, only better. And that's kind of a guiding question that we sometimes have, like, how do you, it basically replaces an unknown by another unknown. How do you write something the same as for adults, only better? And there are really three guiding lights and three dimensions that my colleagues and I try to realize in making programming languages. And really one goes back kind of 52 years now. This is Cynthia Solomon started together with Seymour Papert and Marvin Minsky in the 50s, the programming language Logo, which was the first programming language for kids. And Logo had this battle cry, no ceiling. And that's a very important dimension for us. Like, we shouldn't dumb down things. We shouldn't make things easier by leaving out the hard things, but we should actually give kids everything that we have as adults and try to come up with a good way to package it to make it accessible. And so here you already see kind of one of the first playful robots. It's a turtle that you could use to draw things. So no ceiling is really one of the things that inspires us. The second example is, the mouse with 3 buttons. Now we're at the 70s at Xerox Palo Alto Research Center, Alan Kay, Adele Goldberg, developing another programming language specifically for children called Smalltalk. And in doing so, they not only made a programming language for children, but kind of almost accidentally in the process invented not just the GUI, the interface of overlapping windows of the mouse of menus that we use today, but also the predominant programming paradigm, object-oriented programming. And the great thing about this way was it was a really alternative way to think about computing. It is a very expressive way and a very live way. And this computer, which they actually custom built just for the system, it was always live. It didn't have any compiling run cycles. You programmed the thing in itself. So this is a guiding light that is really inspiring. And of course, the third one is Midge Resnick, Natalie Rusk, the Scratch team at MIT, who have developed this beautiful, brilliant way to program with blocks, kind of really the first visual programming language that actually worked with kids. And so now, today, really block-based programming is all the rage. It's clear that when you start to program, you start with blocks, and then there are all these questions like, what comes next? What comes after blocks? And so what people propose is that there must be some kind of progression. Something where you start as a little kid, and then you start with blocks, and then maybe as a teenager, you have to move on to text-based programming. Here in the state where I live in Baden-Württemberg, that's about 9th, 10th grade. And then, of course, it's clear that adults need to program in a way that at least has curly braces and semicolons and kind of dot notation. And that's the way that it is really programming. This ascension, this progression is taught today in most schools. And the part that has always dissatisfied me is that when you look at these scripts, there really is no progression in meaning, in expression. All these program snippets do the exact same thing. It's just more complicated up here than it is down here. So there is no quality that is added. It's just scaffolding for a parser, for a compiler. And so the alternative way to look at things has been really the battle cry by my friend and colleague, Brian Harvey, who said, in a programming language, things that matter to a programming language should be first class. First class, that's another one of these metaphors that is a little bit problematic, as many metaphors are problematic. It doesn't mean that you have to buy the expensive tickets for the airplane or the train, but it means that something can be assigned to a variable. Something can be the input to a function, can be the output of a function. Then it is first class in a programming language. So usually the things that are first class in programming languages are numbers, for instance, or strings. And so the interesting thing is that when Brian says, if it's important to the programming language, it should be first class in the programming language, is if you think about functions, if you think about control structures, these are very important when you learn a programming language, but in many programming language, you can't assign a keyword to a variable. You can't assign a control structure. You can't pass that into a function. And so this is an alternative way of thinking about a single principle that when we apply it consistently will maybe come up with a different pedagogy. And this is what we're trying with Snap, really. So Snap, we've made Snap for a new course. It's not that new anymore at UC Berkeley. It replaces the previous course that was called Introduction to Symbolic Programming. Now it is called The Beauty and Joy of Computing. We got some NSF grants, and it's a course that is used throughout high schools in the US, also some MOOCs and edX and at SAP. And what Snap really is, it runs in the browser. By the way, what I'm showing you right here is made in Snap. I'm basically using Snap for everything nowadays. It's been translated in a lot of languages. It's free and open source. You can fork it. There's no secret there. But internally, and this is where it gets interesting, this is what I want to show you today. We say it is scheme disguised as Scratch. So from Scratch, we take these things that make Scratch great. The blocks, they look pretty much exactly like Scratch. We take the 2D cartoon micro world that makes it easy to have a variety of projects. Scratch also has some pretty far out and pretty cool concepts like parallelism, something that is not really found in many other beginners programming languages. And it has the liveness that you can actually click on anything and it happens right away. You don't have to compile it first, then get some cryptic error messages and make sense of them. And this is kind of what we call, there's a low floor dimension to introductory programming. But see, there's this other side when we say from scheme, we take the computer sciencey stuff. We take the custom blocks, we take variables with lexical scope, dynamic types of kind of heterogeneous data structures. We take things as first-class lists, so we can have lists of lists, which allows us to model any data structure. But we also have this kind of funny thing called lambda. Lambda, which lets us make any control structure. So lambda, kind of, I don't know if you see me in this little window. This is kind of our mascot. It's called Alonzo. Of course, it looks exactly like the Scratch mascot that's called Gobo. And Brian drew some hair, and that hair is a lambda, a Greek lambda letter. So this is really kind of what Snap is. It is Scratch plus lambda. And I'll show you in a minute what that means. And so this is this other dimension that we don't want to have any ceiling. We want the sky to be the limit in what we can express in the programming language. And then there's a bunch of other programming languages that we're cannibalizing for things that are important to us. Of course, there's much taken from Logo, there's much taken from Smalltalk, also from APL. So we want to have a wide variety of interesting applications, of interesting projects that we can use Snap for. And this is this dimension that we're calling wide walls. So it's a low floor, no ceiling, wide walls. Usually kind of when you have three of these things, you get to pick two and you got to compromise on one. And up to you. You be the judge. I'm going to show you now some things, and afterwards we can think about whether it satisfies all of these 3 dimensions. So this is Snap. This is how it looks. Some of you might know it. Some of you might not. It's basically kind of looks, if you've seen Scratch, it looks pretty much exactly the same, and that's the idea. So people feel at home in Snap. Here's something that we call the stage. On the stage, there is something we call a sprite. That's kind of like an arrow thing. Here is an area where we can stick these blocks together. We find these blocks at the left. There's a category, a motion category, and we click on something, it immediately happens. If I click on this move block, it moves. If I click on the turn block, it turns. I can move again. I can kind of move it back to the center. Things immediately start to happen. We have other categories. We can change the looks. We got sound, pen. We got control category. Here are events where we can attach scripts to like a mouse click or a key event. We've got some loops here. We can sense things. We have operators. These are these and round blocks that can be inputs to other blocks. What's special about Snap is that we can build our own blocks. And it's also called Snap Build Your Own Blocks. In fact, it used to be called Build Your Own Blocks, BYOB, before we had to rename it to Snap because some teachers, and I guess some parents, didn't understand the joke. So we can make our own block. And so I'm going to make a new block. And for example, in Snap, we also can make reporter blocks. Those are expressions, functions that return a value. So I can say, I want to get the squared version of a number. So I can give it a name. I can click on it, and I can click on num to make it an input. I could even say it should be a number, so it kind of gets a different way how it looks. So here now is our squared block. It doesn't yet do anything. This is an input. On the outside is a slot where I can type in something, and on the inside it becomes a variable. So now I can define it, and to square something, I can just multiply the input by itself. This would be a very simple function. So now I can click on this and I get 5 squared. That's 25. I can try this. I get the numbers from 1 to 10. And in Snap, we can easily map, a list of numbers over a function. So now I get all the squares from the inputs of 1 to 100. We recently, last year, made it so that for really only arithmetic things and many mathematical things, we don't need loops and even higher order functions anymore. Instead, we extended the domain of these operators to lists, to vectors, and even matrices. So we can directly say, I want to square the numbers from 1 to 10, and now I'm directly getting all the squares. This is an idea we got from APL. So I said it also works with matrices. So just going to make a matrix so I can have the numbers from 1 to 12 and reshape it into a table. So these are the dimensions. It says it's 4 rows and 3 columns. So this distributes the numbers from 1 to 12 over a list of lists. And I can take this as an input to my squared block. And now I'm getting all the squares of the numbers 1 to 12 arranged in the same matrix that is an input. So this is kind of a way how you can extend the language by making your own blocks, build your own blocks. That's the idea of Snap. So you look at the control category, something that often comes up is, so here we have these loops. Loops are very important. You have to learn about loops. We have the forever loop, repeat loop. We even have a for loop. We don't have a while loop in here. So how can you have a language that doesn't have a while loop? And the cool thing with this lambda feature that we have is that we can make these things ourselves. We can make any block ourselves. So I can make a while loop. I'm going to say while, it's going to have a test, and it's going to have an action. So here's my while loop, needs some inputs, and the action should be something like a C-shaped block. I can even give it a little arrow that it looks like a loop. So here, now it looks like a loop. And the test should be an input. It should be a predicate that I can evaluate to find out whether a condition is met. So I'm also going to make test an input. It should be a Boolean, but I'm going to need to evaluate it several times at every iteration. So it could be a predicate, or I'm going to make it an unevaluated Boolean. Usually inputs are evaluated before the function is called. In this case, I'm getting the unevaluated input so I can unpack it on the inside. So this now is my while block. Let's make a little test case. I make a script variable. I'm going to put the pen down. I'm going to say while that variable a is less than, say, 300, I'm going to increment it. So I'm going to change a by 1. I also want that sprite here, that error, to move a step. So it's going to keep moving longer and longer. And so it doesn't fall off the stage. And we want to make it turn 121 degrees. Now, if I click on this, nothing happens because I haven't defined while yet. So let's define while. Here's my test. That's the a is less than 300 block. So if I want to find out, whether that is true, I need to call it. I need to call test, and I can say if that test is met, I want to run the action. And now this is something provocative because the action is this stack of blocks. So we have blocks, a stack of block as an input to this function. And this is exactly what I was referring to when I was saying we have first-class procedures in Snap. So I'm running the action. So now this is the first time that we've done something. So how can I do it until the condition is no longer met? I already know what to do. I can just take the while block and just copy this again. Duplicate while, I'm calling the test, run the action. It goes into this slot and the action goes into here. So you see, this is really another provocative way to look at things. We're defining a control structure recursively. And this is kind of this no ceiling way that I've been talking about. Let's actually try this now. I'm applying this, and let's try this. So we've just made ourselves a control structure that is present in really all professional programming languages that for some quirky design reason isn't present in Snap, but we can make it ourselves, and it's not even hard. And so sometimes people think we just left it out so I can do this example. But the point is that once we have this way to think about programming, to think about control structures that aren't the language, but are just something that you can build yourself, you sort of come into the habit of just writing your own control structures, your own custom things for, any project that you want. So, for example, let me give you an example. I want to make a control structure that makes a grid of a cell size. That's a box. I want there to be a reference to columns and to row, and I want an action to happen. So the action is, again, going to be a C-shaped thing. Now I want the box, that's kind of a size of a cell. I want that to be a number of pixels, really. And so I already have this here. this is a grid, and I want columns and rows really to be outputs. Maybe I should spell them correctly while I'm at it. So I want this to be an output. It's an upvar, a variable, an internal variable that is visible to the caller. And same thing with row. So you can kind of maybe see where this is going to. This is going to be a kind of like a for loop. Let me actually clear this stage and reset it. Lift the pen. So let's say maybe I want to have like a grid of a length of each cell should be just 45 pixels wide. So I want to write down something. I want to write join the coordinates, join the column and a comma and the row at each cell. So if I click on this, nothing happens because we haven't defined it yet. So let's define this. In order to define this, we will need a bunch of variables. So I want to kind of start at the lower left of the stage, because in Snap, kind of Y goes up. Usually in computers, Y goes down. In Snap, kind of we're like in the first quadrant, so Y goes up. So I want to define the origin. And I want this to work with any stage dimensions. So I can ask kind of the stage for its left side. So this is left of stage. Incidentally, now this is minus 240. And I also want it to be at the bottom of the stage, which kind of minus 180. So I want to define the origin for my grid as kind of a point. So I can make a list of two coordinates that has left of the stage and the bottom of the stage. So what I'm now getting is a list really of two items. So this is my origin. I want to know, I want to initialize actually the column to 1. Start with the first column and start with the first row. And now I want to find out how many cells kind of fit on my screen on the stage. So I'm going to make another variable that's going to be called rows. I'm going to set the rows to it's really the height of the stage. Divided by my box. And so I want to add one more so it always kind of passes just one beyond. So it fills the screen actually. These are the rows. I'm going to do the same thing for the columns. Just copy that. That's columns are going to be the width of the stage divided by the square box. So now I've initialized all my variables. Now I actually need to do the work. So I need, guess what? The while loop. So I'm going to have a while loop, and we already made that. So tested it, it should work. So I'm going to say while the rows, while my current row actually is less than the number of rows, I want to increment that row. And likewise, we do the same thing for while for the columns, saying while the current column is less than the number of total columns. I also want to increment that. And then, at the next line, I probably want to reset the column again to 1. So I'm duplicating this here. And now I want the sprite to actually go to that coordinate. So I'm saying go to a position, and a position in Snap can also be a 2-item list of coordinates. So I already have my origin, and remember we can just add vectors. So I can say I want my origin plus a list of my current coordinates, which is the column and the row multiplied by my box. Okay, so this should be the coordinate that I go to, and this is where the sprite is going to run the action. Okay, folks, I've never tried this before. Just basically thought about this an hour before this talk. Let's try this, whether it works. Boy, wow, look at this, and it does work. Okay, so I made one mistake. They're slightly off. So we've made a control structure, but my origin, I need to subtract half the box from that. So I need to subtract half a box, half the cell. And I could do so because it too is a vector. So let's try this again. And I'm getting these coordinates now. I've made myself a new control structure, and I can change the size of this. So this now works. I can say, okay, what if I make it wider? What if I make it 60? I'm getting a different distribution of things. So this is just, might seem a little nerdy, but it's actually a kind of a cool thing that we just habitually get into the habit of writing our own control structures. Now, another really powerful idea of programming is, so we can extend the language. We can make our own language by building our own blocks, even building our own control structures. And this other really great idea is about digitalization. So digitalization is something that I talk a lot about because everybody talks about it a lot. And I really think it's a great subject, but what does it even mean to digitalize something? And really, it's about numbers, right? So it really involves taking a signal, sampling a signal, and converting it into a number on a range of a lower bound and an upper bound. And it's really something intrinsically humane, right? We have 10 fingers, so no wonder we have a 10-digit number system. There are also other number systems, like here's a dice. Dice have been around for a really long time. So this is a 6-number system, maybe half a dozen. I guess some people muse that maybe teachers in Germany make their grades on a scale of 6 because they can use dice for it. On the other hand, dice have been around for a long time. It was, I think, 49 BC that Caesar crossed the Rubicon and said the die has been cast. And maybe he wasn't so much making a statement about resolve, but a vision about digitalization. So actually, let me import some costumes of dice to play with this idea. So this is a dice costume. I'm going to just rearrange these so they're in the right order. 1, 2, 3, 4, 5, 6. So here's dice. So now what I can do, I guess, is instead. So this is a control structure, right? Instead of writing something here, I could do something entirely different. I could say switch to a costume, and let's just take any random number, 1 to 6, because that's what we have, and stamp it. So now I should get, I should kind of fill my stage with dice. So I want to put them closer together, really a stack of dice. So I have something that in the sprite that it kind of knows its own width. So this is my width. So what if I take this and try this again? So now they should be closer together, and they are. I still want them to be closer yet. There might be some, so I'm going to multiply them by 0.7. And now I'm getting kind of a wall of random dice. Fill my stage with random dice, and that's kind of a neat thing. It's some secondary patterns emerge, and this is where I want to try something new. So I have this portrait here of our one of our founders of SAP, and I actually want to import this. I'm going to make another sprite. I'm going to clear this. So I'm going to name the sprite here. This is going to be dice. That's a dice. So we want to import the picture into this other sprite. This is Hasso Plattner. So I'm going to call this sprite Hasso. I'm going to go to the center. I'm actually going to adjust the stage size. So it's just exactly the size of this portrait. And I can make it bigger again. And I'm going to adjust the transparency a little bit. So I'm going to change the ghost effect to so just barely visible. Okay. So now I'm switching back to my dice, and hey, I have this cool function. So instead of switching to a random costume, what if I took this idea of digitalization, of sampling something and turning it into a number and stamping that? So I'm not taking a random costume, but I'm sampling something from here. I can sample something by taking the hue at mouse pointer block. So there's also a brightness at block. And I want the brightness not to be at the mouse pointer, but at myself. Not myself, Jens, but kind of myself, the dice and the position inside my grid block. So I'm taking this brightness that is on a scale of 0 to 100. So I want to convert that into this other scale of the dice of 1 to 6. So I'm trying to divide this by 20. Then I'm going to round it. And then I'm going to shift it by 1. And then I'm going to stamp it. So what I'm trying to do here is really take digitalization literally. Because if you look at this dice, so actually the number 6 has more white space than the number 1. So 1 kind of is more blackish than 6. So let's try this. So now I'm filling the stage with dice, and the number, the dice face, is kind of corresponding to the brightness of Hasso at that point. So Hasso is still shining through. I'm going to make him fully transparent. Oh wait, that's the wrong sprite. Make Hasso fully transparent. And it's kind of, we can see there's something here, but it's we can't really find out who he is. So maybe the dice is just too few of them. We need to increase the resolution. We can do that by changing the size. So right now the dice are at 100%, so let's do them by 50 and it should adjust automatically. So now I have increased the number of dice, and I'm going to see what happens. I can actually make this a little faster, so you don't have to watch this all along. So this is getting somewhat better. Not good enough yet. Maybe let's have it again. Let's make it 20%, so we have many more dice. And do one more round. And so one thing about this digitalization is that it sometimes helps to have a lot of data, to have a high resolution. So because what now emerges out of this is a fairly good rendition of Hasso diced, where we kind of render this photograph in 6 shades of gray, but it's actually the face of the dice that is not just representing the grayness as a number, but actually is the grayness. And this is a kind of rendering that we're calling dithering. So here, instead of Julius Caesar, we now have Hasso Plattner, and the die have been cast. So how cool would it be to not just do this theoretically, but to actually find out whether it works? So what I've done is I've actually bought 5,000 dice. So here's some left. And by the way, if you think about a micro grant from Meet & Code, 500 euros will pretty much exactly get you 5,000 dice if you want to try this at home. So apply for a grant for 5,000 dice. So so I bought these dice and printed out the whole thing, Hasso by numbers. Here's kind of this whole thing, and then this is my son. We kind of had to glue it together and put it into a frame, and the whole family kind of puzzled and took the dice and kind of turned it so it exactly shows the number that is shown. And it was a whole night's work. And at the end, there was only a few left. And actually, I'm going to stop sharing now. Can I see myself? No, because lo and behold, folks, for the first time, this now sees the light of day. It's standing right beside me. Here is the actual real-life rendition of diced Hasso. And we wanted to find out whether it actually works to take real dice and to really put them together, whether we would see something. We're actually kind of proud that we do. It's kind of working. Just wanted to let me share my screen again. So this is a little movie that might be easier. Wait, how do I start it? So you can see this is up close. You basically see the dice, and then as you move away, the resolution increases, and sort of out of these 5,000 pixels, a picture starts to emerge. And this really kind of is the essence of digitalization: sampling a signal, converting it into a number on a scale, and then representing it in that number, and then we can reproduce kind of the original picture again. This was actually literally, I think, the night before the COVID lockdown. We wanted to show this in Waldorf for teachers, and we were really proud of it. And then lockdown was, so Hasso was in my living room until my family decided we can't have Hasso in the living room anymore. So he's been on permanent exhibit in my basement ever since, only to be unveiled today for you. So coming back to the question, like, how do you make software for kids? So we say the same as for adults, only better. I told you about our 3 dimensions, kind of low floor, no ceiling, wide walls. And so really the question, as we're playing with control structures, as we're playing with data structures, with linear algebra even, is at one point, why should we have had kids? Why should kids have all the fun? Isn't this also a good way for adults to program? Isn't this a good way for all of us to think about programming? And this is something that I'm personally really, really excited about. I think it's one thing to think about CS for all, meaning how to let every kid learn computer science. But it's also one thing to think about changing CS for all, meaning for everybody of us. Because as you know, somebody once said, professors have only studied and explained history. The point really is to change it. Since I'm giving this talk mainly to Germans, you all know it wasn't Steve Jobs, but Karl Marx. Thank you very much.
Oh my God. Jens, thank you so much for that. I think it was truly packed session with just lots of inspiring insights. And, you know, as no programmer, I was really shocked seeing you creating all that stuff and making it seem so easy when I bet it's not. And the last thing,
of course it is.
That,
no, it's not.
You know, but the dice piece of art, like, that's extraordinary to just do something like that at home. So I was amazed, and we are fortunate enough to have Jens with us for a few minutes longer. So I'd like to open up the platform for questions. So just please type them into the chat. Anything you want to ask Jens, that's an amazing opportunity for you to give all your questions. So feel free. And we have still 8 more minutes to answer some of them. And don't be shy. We have a question: would it be possible to invite Jens to hold a workshop on creating such masterpieces for students?
Sure. I mean, this is the really great thing that I can't stress enough is that I'm incredibly privileged, incredibly happy to be working at SAP on Snap. This is something that you know, can't be valued highly enough. It is literally my job to make this. So yes, I'm happy to share this. I'm happy to hook up with people and to do workshops. And we're offering them also. So come to ours or invite us to yours. Maybe at some time even we're allowed to move out of our cubicles again into the real world. Bring dice.
Okay, we have another question. This is curious about the biggest program that you ever created with Snap. How many blocks does it have, and what was it for?
It's a good question. I really don't know. I'm not the one to write these super big projects. I usually try to write elegant projects that use just very little code to do a lot, as you might have seen me do now, or I hide these blocks by building functions around them. The programs that I've seen that really are humongous and are huge are by kids that keep copying blocks, and they copy blocks when I say, you know, well, you could turn this into a function, so you can call it several times. But the humongous projects are mostly kids with incredible energy designing games that are often mind-bogglingly great. And I don't understand how they work. So the biggest projects that I've written, actually, the one that I just showed you, where you can drag these letters around, that's a pretty big project, because that took me a pretty big effort.
I see we have some comments from meanwhile your presentation, and Olaf was asking, would you mind sharing the code of the presentation?
In fact, no. Let me save this right now, and I'm going to say this is. Wait, can we say this is dicing Hasso? Okay, I'm going to say dicing Hasso. Does that sound like kitchen? I don't know. Whatever. So I'm going to share this right now, and I'm just going to paste it into the chat so you can just use it.
That's great.
Let me share this now, and let me publish it. And act. Can I? Yeah, here's. Okay, here it is.
Amazing. Okay, do we have any other questions to Jens? Like, we have 4 or 5 more minutes, so if you want to ask anything, that's the time. Don't hesitate. I think that meanwhile, I just have a question as typical no programmer, but as a person who just works with people and try to educate young people with coding. As I saw the pictures of you doing all that stuff with your kids, with your son, what do you think? What is the best option to just get kids and teenagers interested in Snap and coding, and to just show the real value of it? What's your key method?
It's a great question. Yeah, it's a really great question. And, you know, honestly, I don't know. To be honest, my own kids have mostly other interests. And maybe because dad does all the programming, so kind of, you know, my oldest son really is an artist. He's actually pretty good. He actually likes to draw and to paint. And my younger son is a musician and kind of is more into sports. So I really believe that, you know, programming and computer science is a treasure. It's great. And I think it's, as my friend Brian says, it's your birthright as a human being to be offered an insight into it. But not, you know, not everybody has to like it. I think it's okay if you've seen it, you say, yeah, that's great, but actually I like to play soccer, or I like to, you know, do music. I think that's also really great. So it's something that you can offer to kids. You can try to explore together, and I think that's a good way to really explore different things together. And you should explore many things, and not just coding. I mean, you should explore hiking. You should explore, you know, riding a bicycle, swimming. I mean, I've heard that many people aren't swimming anymore because of the COVID crisis. So you really should teach your kids swimming. That might be even more important than coding. But, you know, there's one thing that if you try it together, if you learn together in a family, if you talk about it, this is something great. Don't start too young. When you start too young, it's often the parents being ambitious because they work at SAP or at some tech companies. And, you know, this is important. This is what I do. I think it's perfectly okay if they're teenagers, because once they're teenagers, they're, as we say, they're really natural abstractionists. That's when they're kind of, they want to explore things like this.
Yeah, that's true. I think I agree. And I think that we can, last one question. What events are possible to join that you mentioned before?
We have, we should share this maybe afterwards. So we have virtual events like the MOOCs that we do in OpenSAP. There is also a conference, a full-blown conference coming up for just a little fee. It's the Snap Conference, the annual Snap Conference. It's on July 31st on Zoom. It's hosted by UC Berkeley with people from all over the world. Even in the days before, there is a Young Thinkers Learning Festival organized by SAP Young Thinkers, which is completely free to attend. That is also around Snap and around programming and around these things. This is a great event to join. You'll see many researchers, many educators. You'll see us sharing ideas and spreading the beauty and joy of what we do. And then there are other events coming up. Like usually we do another event kind of in fall. They are right now virtual, which is pretty good actually for people from other countries to join. At one point, I guess they will be in person again, but there's probably going to be a virtual component to it or some hybrid thing to it.
Okay, so Jens, if you would be able to just provide me with the links to the events, I think that we can post them on Meet and Code social media platforms for you to just check it afterwards. Because I think it's super helpful for our today attendees.
So I'm just going to paste this one thing here. Okay, everybody sign up. Now, do it now. Snapcon.org.
Okay, so I think that we're almost over. So we'd like to thank you, Jens, because that was amazing. Like even for a person not fully interested in coding, it was super interesting. So I'd like to thank you. I also like to thank our partners and especially you guys, our Meet and Code audience, just for your time and attention this afternoon. We've enjoyed hosting you, and just I hope that you walk away with feeling a bit more inspired and motivated to discover Snap on your own. We look forward to seeing you in the next Meet and Code Purpose Talk. So just please remember to check our socials to have all the updates. And yeah, just have a good one. Thank you again for being here with us. Thank you, Jens. That was amazing. And I hope to see you soon.